Hi, and welcome back to AI in 5. I'm your host, Simon Chris, and joining me today is Nitin Kumar. Now, Nitin is the COO and co-founder of a new company called Riverkin. And we're going to be talking about the exciting work that they're doing using AI to ensure water quality for all of us. Hi, Nitin, and welcome to AI in 5. Thanks for joining us.
Thank you very much for having me, Simon.
And we find you today in Zurich, is that right?
Yes, I'm in sunny Zurich today.
Lovely, lovely, lovely. Let's jump right in. We've only got 5 minutes. The work that you're doing in the biotech area, particularly around water quality and using machine learning and models to understand water quality, really quickly talk us through that. How's that field kind of panning out?
So what we are trying to actually do is deploy our proprietary sensors that collect real-time water quality and availability data and use those sensors to optimize industrial operations with freshwater systems. So an example is that if a company X withdraws X amount of water and releases Y amount of pollution into the river, can that impact on the water level and quality be quantified in real time using machine learning and AI? And that's what actually we are trying to do, optimize entire water value chain operation for companies around freshwater systems.
Yeah, wow. And I can see huge use cases around mining, where they're pumping so much water in, so much water out. Even smaller ones like around wineries, where during wine season they're pumping so much in and out of the water. Where else are you seeing the big applications? Who's kind of the big commercial application?
The two examples you have already given, we also see big application in hydropower energy,
Okay.
where we can see that the fine sediment can be managed using the data produced by our sensors. And we actually also starting to see application in drinking water quality management. So what happens is that all the water processing facilities that take water from freshwater systems, they need to monitor the quality because the downstream processing or the cleaning processing of the water to make it drinkable actually depends upon the amount of sediment in the water. And they have to optimize the entire process and the value chain according to how the river water or the lake water looks like at that particular moment. And right now, that whole process is manual. And with the help of our what we call as water data ecosystems, actually they can optimize the whole process in real time.
Yeah, wow. And, I can think too that it could just help in some impoverished areas where water quality, because, the drinking water comes from the river, knowing in advance that something has happened further up the system would mean that, the people at this spot would know not to drink the water today or whatever the case may be. Is that kind of, I'm getting that right?
You're getting it very right. All I would say is that we want to bring water as close to the weather as we can. Right now, every day we look at the weather apps to know, what do I have to do? What should I wear? Warm clothes, cold clothes, how should I walk? We want to have the same level of understanding around water. I'm gonna go and swim in this lake.
Mm-hmm.
Should I swim there or not?
Yep.
But can I use this water for drinking purposes or not? Isn't it? And when you think of a weather app, what we want to have is a water quality indicator shown there of the water systems around that location, any particular location. That's like our vision.
Yeah, wow. And so, if you were deploying this in a lake, say, and I know all lakes are different sizes, but a reasonable sized lake, how many sensors are you talking about? Well, how much data is being crunched?
Good question. It depends upon how much depth we want to have on the data. Our current estimate says that actually one sensor every 5 kilometer distance would be the most ideal because then you have a resolution at a 5 kilometer range.
Yeah, wow. And the models underpinning this must be fairly extensive. I mean, I don't imagine you're in the generative AI space, more the traditional AI and machine learning. Would that be right?
Yes, it's classical machine learning and AI.
Yeah, incredible. And how long has it taken you to build the data model for this?
So we have the sensors and the data collection part ready that we are starting to deploy for our clients. And modeling is something that we plan to bring in the next versions of our product.
Oh, so it's very early days. We should definitely be
It's very
keeping an
early days.
eye on what's going on here.
I would say so.
This has been fascinating, and I love the potential to help people in impoverished areas. I think that's just a wonderful go forward, kind of a side benefit to also helping industry do what they've got to do. I have a question I love to ask everybody that comes on the show, and that is, what is your best tip for somebody who's just starting their AI journey?
Someone who just get real world experience. Do not work with the clean, organized data sets one finds on internet. Really get real world experience and get ready for a journey that requires constant learning and growth. So I see more and more people trying to tap into this space, but it's that space is quite challenging to survive in because every week there is something new coming, new papers are coming
So
out, new
true.
models, new tools. So if you're not up to learning daily, you might as well not don't want to join this space.
Yeah, absolutely. Great advice. Nitin, thank you for being on AI in 5. It's been wonderful. Look forward to chatting with you again.
Thank you very much, Simon.